Welcome to RCR Wireless News. I'm Martha DeGrasse, and our topic today is Building Tomorrow's Networks. I'd like to introduce you to your panelists for today. Paula Dublin is Assistant Vice President for Antenna Solutions at AT&T. Paula, thank you so much for being here today.
Thank you, Martha. It's good to be here. I'm looking forward to spending a bit of the afternoon with y'all.
Well, thanks. We are too. Randall Schwartz is founder and principal consultant at Wireless 2020. He's our analyst today. Randall, thank you very much for joining us. Thanks for being here, Randall. Tony Perez is here from the city of Seattle. Tony is the immediate past president of the National Association of Telecommunications Officers and Advisors, and he runs the Office of Cable Communications for Seattle. Tony, thank you very much for making time to join our webinar.
Thanks for inviting me. I hope I can contribute to the conversation.
Thanks, I'm sure you can. And Kashif Hussain is here. He is go-to-market leader for wireless mobility at test and measurement solutions provider Viavi, one of our sponsors today. Kashif, thank you for being here.
Thank you, Martha. Glad to be here.
Thanks. And Robert Booth is here. He is Vice President Infrastructure for antenna maker Galtronics, one of our other sponsors. Thank you, Robert, for joining us.
Yes, it's a pleasure, Martha, and we look forward to the rest of the panel this afternoon. Thank you.
Thanks, so do we. And I'm Martha DeGrasse with RCR Wireless News. A quick word about RCR Wireless News. We are a premier news source for the wireless communications industry, providing carrier, network, device, test and measurement, telecom software, and IoT news. Find us at rcrwireless.com and at our newest website, industrialiot5g.com. Our Twitter is RCR Wireless News. My Twitter is mdegrasse_RCR. Also find RCR TV on YouTube, where we have more than 6,000 videos on the wireless industry. Now, before we begin, I would like to call your attention to a feature report on this topic published today on our website, Building Tomorrow's Network. A few quick key takeaways from this report. We're not going to spend too much time here because we're going to get into a lot of these topics very soon. But one overarching theme that we heard again and again was that small cells are very likely to be building blocks of 5G networks, even though we don't know exactly what 5G networks will be yet. Just yesterday, AT&T presented here at the Texas Wireless Summit in Austin and said that small cells could be deployed as close together as 100 meters apart in order to support V2X communications for connected cars. So I thought that was a very illustrative example of how important small cells may be for next generation networks. Carrier approaches and timelines, however, are very different. Different carriers are at different points in the deployment process and are taking different approaches, and we go through that in the report. Jurisdictions are seeking clarity and transparency from carriers, and we're going to hear more about that from Tony in this webinar. Concealment solutions are helping the carriers a lot as they work with the jurisdictions. We're looking at a concealment solution right now from Stealth. There's a small cell inside that couple, obviously. Form factors are getting smaller, and that's helping a lot. And small cells need to be tested in the context of the overall network with one another and, of course, with the macro network. At this time, I'm going to turn the presentation over to Randall Schwartz at Wireless 2020 to outline some of the topics that we're going to be going over today.
Yeah, good morning to everybody. This is Randall Schwartz from Wireless 2020. Thank you, Martha. Just as a little bit of background, Wireless 2020 is a broadband wireless consulting company. So we look at trends and key trends in the industry and what's happening. And our subject today, certainly is critical and to some of the key developments in the network, in networks today. So let's go to the next slide. This should really be high times for mobile operators. 4G networks have been deployed. Usage is going up. We should just be milking these networks and looking forward to 5G networks, but really nothing further could be from the truth. There's a tremendous challenge for the operators to keep up with the infrastructure investment that's required to keep up with, a 12 to 15-fold increase in traffic that we're in the middle of. And not only that, but phones are becoming absolutely indispensable to almost everybody for their personal use and for their business use. So this capability to sort of keep up with this ever exponentially expanding demand becomes critical. And to do that, actually placing whatever infrastructure it is that we're placing is much more diverse. So whether we're talking about DAS nodes or small cells or Wi-Fi access points, placing them is almost becoming more of a challenge than the technical issues for actually building the network. We can go to the next. So one of the key trends that we see, and this tremendous challenge, and we'll have AT&T here to talk about some of this, but this tremendous challenge that the operators face with keeping up with the ever-expanding CapEx to keep up with this capacity growth. And so one trend that we see is the trend towards shared infrastructure. And that could take several different kinds of guises. It might be a neutral host solution, whether that's an in-building DAS system or publicly placed small cells, neutral spectrum, things like CBRS and multi-fire that are unlicensed spectrum that any of the carriers could use. That's another form of shared infrastructure that the operators might take advantage of. And what we refer to as common infrastructure, and that is, can we sort of put down a common infrastructure that any of the operators could build on? We could think of this kind of in the context of the tower business, the way that it's structured today, where a separate party may own the tower, but any of the operators could actually build on that. And this could be something that the municipalities may fund to make it easy for operators to expand their infrastructure in their neighborhood. Or is this something that we'll see more of in the future? In any of these models, what sort of binds them together is that the operators can lower their CapEx, and basically they can use adjunct network infrastructure elements that can add on to their own network. So just to highlight, one of these ideas, this idea of a municipal common infrastructure, one of the great challenges for both operators and for municipalities is the tremendous volume of requests that they get for placing small cells, and for the operators the need to put down a lot of small cells. So one of the challenges that you get for small cells is, first off, even within the operator, you have a few different groups. So, the network guys may say, I need to put a small cell here for coverage or for capacity. The backhaul guys may say, all right, where is their fiber? And the regulatory guys may say, where can we get approval, to put a small cell? And it's not too often that all three of those are at the same location. And so what you might, we're starting to see cycles where it might be 12 to 24 months to get a small cell site approved, and that's just not helpful. So one possibility is if the idea of developing a common infrastructure where the city deploys a pre-selected fiber connected and powered cell location. Maybe there's a closet that the operators could easily place a small cell in that's already pre-wired and pre-approved. And so this could have the tremendous impact of saving costs for the carriers, speeding deployment, and streamlining the approval process, which would certainly help the municipalities. And it becomes a potential revenue source for the city. So when you look at all of these, it's very interesting and very interesting placing it in the context of where we see networks developing, both from the standpoint of the technology and how that could be deployed. That has to be examined. The business case around is deploying this kind of common infrastructure. Does that provide a return on investment if a city or a town wanted to do that? So all of these things become very interesting for us to consider. And I wanted to present this. This is kind of a background of some of the challenges that we face, and certainly will lead into our other discussions this morning.
All right, thank you very much, Randall. At this time, we're going to move on to Paula Dublin of AT&T. Paula?
Thank you, Martha. So good afternoon, everyone. For those of you who may not be familiar with me or I've not ever had the pleasure of meeting you, we have been working very hard on from a hetnet deployment perspective, and it's one of those things where it's literally changing on a day-by-day basis. If I look back at where we were, 3 years or so ago versus to where we're at today, it's literally some night and day differences. So my organization has deploys basically DAS and small cell primarily in the in-building space and then along on the campus space as well. We are moving toward, a general, small cell deployment, both indoor and outdoor. We're working through that. But I think it's important that we get our language together and get our language straight about, what we think about, what we talk about whenever we talk about hetnets. And hetnets are, simply one of those, it's a toolbox for us. And it includes, small cells, it includes cows, it includes Wi-Fi, it includes your traditional macros, it includes DAS. And I'm sure over the next couple of years, it's going to include, a number of other solutions that are in the toolbox. So really exciting time for us, and I think really exciting time for the industry itself. So talk a little bit about densification. Martha, during the introductions, made the statement that this is laying the foundation for 5G. I totally agree with that. And so densification is really getting to deeply dense networks. That means that there are our nodes are closer to our customers, to the end users. And so once again, just to recap on solutions in the toolbox, there will always be traditional macro cells. There will always be traditional distributed antenna systems, and there are going to be a lot of small cells out there. And we make the distinction by the term, and you'll hear us talk about it, is down below the clutter. And so down below the clutter, you'll see that is below 70 feet. And in particular, that area that's 20 to 70 feet, and then you of course got you've got the indoor piece of it as well. So, and it's all also about the power of the radios that are out there. It's about how far you can, the radius and where you're able to propagate signal. You can see there, from a macro perspective, I don't believe not everyone is familiar with the fact that, given the topography and terrain, a macro can go out as far as 20 miles or more. You get into the micro pico space, or the 20 watt or 1 watt to 20 watt radio space, and you're looking at, you're going to have one of these, every half mile or less. And then you get in the indoor environment or the smaller watt radio, and it really just can really depend on what the building has and how it's constructed, and really at the end of the day, what challenge are you trying to solve for? What are you trying to provide for your customer? And then of course there's the Wi-Fi outdoor hot zones. We have a number of them all over the country. And so when you get into the hetnet, all of these have to play together. They all have to be optimized together. They are a network in and of themselves, and they are a community in and of themselves. So it's really going to be about us getting our language right, across the board, whether we're dealing, as we deal with, cities and municipalities and of course, other government entities and even within our own industry. Let's get to a common language where we understand what we're talking about and we don't talk past each other. So Martha, if you'd like to go on to the next one. This is just another way of taking a look at it. So, densification and the clutter and what it looks like. So we firmly believe that small cells will help us and every other carrier out there bolster network capacity. And it will help us meet the customer and business demand that's coming out there. It will contribute to much faster connectivity, and it does set us up for 5G in the future. So this is just an example of one we completed recently. This is a 21-acre community park in a major metropolitan area. And this is one, I went ahead and put it in here just to kind of demonstrate, you know, how long it took to bring this one to fruition. Our end-to-end cycle span on it was well over 12 months. Of course, that included our design, our pole selections, attachment agreements, lease agreements, you know, ordering our equipment, installing, and then, of course, getting an extension of our existing fiber over to what we call the AT&T hub location. So, give you some examples. There's what it looks like in deployment. It does meld in very nicely with the environment over there. It has redundancy, it has diversity, and one of the really cool things about it is that prior to this deployment, we had about 75 megahertz there, and then post CRAN, and we would call this a CRAN. It's now up to 440. So you can see what it does, to capacity and to bandwidth. So this is another, this is a photo sim, just giving you an idea of what the next generations look like, and these next generations, quite frankly, are here today. This is what, what we're doing. Give you an example of up at the top there. This is your existing view. This is what it looks like today. When and if we get our permissions to build this out, you'll see the proposed view there on the left-hand side on the lower left-hand corner, and then went ahead and just identified what you're seeing there on the structure. So you can see the antennas and you can see the radios. So this is this is another view that comes into play. You can see what it looks like today. You can see what the proposed view looks like, and then you can see, of course, we've identified the the antenna and the radios that are involved on it. So this started out as a doodle for me that says, in densification and deeply dense networks, and what you're looking at here is basically, a city block. A city block that's 3,100 feet, and then, of course, it's around 1,500 feet across the top there. And then, the symbols inside are buildings or parks or whatever you'd like to call them. And then the various, sets of arrows that you see there would be prime locations for deploying a small cell. So, kind of my way of keeping it straight in my mind is, a goal densification selection. This would, this is absolutely pure gold here. We're on corners. That means that we can, that we can actually propagate, north, south, east, and west, up and down the city blocks as necessary, and really pretty much provide a really good service offering here. So then you slip over into the silver side, where what if you can't find a deployment location? So that means that you have to go mid-block, and you're essentially propagating either, east to west, west to east, or north to south. So you don't have, that the corner locations where you can, you can basically, establish one location and be able to go north and south, east and west. So and then the next one is the bronze, where it's basically a mix. Yeah, you get some great locations, at corners, and then you have to kind of go in and pick off existing. Sometimes you have to place new. I mean, it just all depends. And so you can see the difference. In a gold, there's 8 potential, densification locations that you would have to, that you would have to organize around. Then if you move into a silver, that number jumps up to potentially 25. And then, of course, in the bronze, it comes down to 19 probable sites, including, the four corners and some of the mid blocks. Sometimes you've got existing structures, sometimes you've got new. So I can tell you this, is that the way that we engineer today and the way that we're going to have to engineer, as we build out deeply dense networks is going to change. It's got to become much faster. It's got to become, I hesitate to use the word agile, but it's got to get faster because, literally in the densification world, it certainly appears to us that location, and feet matter. Not just, I'm not talking about the feet that we have shoes on. It's literally a measurement of a foot or two can make a difference in these networks. And so there's some skill sets that are going to have to revolve around this. There's some re-education that has to occur. So, it's an exciting time. I don't think we get this opportunity too terribly often. And it's really going to, how we handle this is going to be a reflection on all of us, whether it be carriers, whether it be cities and munis, and of course, the government regulators or our state regulators and that sort of thing. So it's going to take all of us to make this happen. And Martha, you guys had asked me to talk about the skill sets that that are necessary, to do one of these. And
Absolutely.
particularly once you build this, you got validation and optimization that needs to occur. I'm going to go one step further and say, yes, the network has to be validated. Yes, the network has to be optimized. But we as individuals in this industry also have to validate and optimize ourselves in terms of the skills. And so this is some excerpts from a place called Guru Careers. It's based out of, it's a work that was done out of the UK several years ago. I think it's one of the best forward-looking views that I have seen of what necessary skills are. So that and of course, there's some good old common sense skills in what I call the hard eight that people need to keep in mind. The one takeaway that I want you all to have is that if you're not learning something new every day, you are probably already behind. Martha, I'll hand it back over to you.
All right, great. Thank you very much, Paula. And we are going to be sending out these slides. You had a lot of good information there, so people will have a chance to look at those when they get to them. Thank you.
You're welcome.
Tony, I'm going to hand it over to you now. Are you there?
Yes, I'm here.
Terrific.
And thank you, Martha, for that straight out of the Chamber of Commerce, that beautiful picture of Seattle that you have. And that's from my neighborhood in the city called Queen Anne. I am here wearing two hats, basically. I'm with the City of Seattle, but I'm also, I think, on a broader level with the National Association of Telecommunications Officers and Advisors, I think, articulating some of the views and concerns of local governments. And I don't have a presentation, so I'm glad for the picture, but I just wanted to make a few points from our end. I think one is that most local governments get it. We understand that the explosive growth in demand for mobile data is requiring the shrinking of cells and getting them closer to the user, and that's driving demand for increased deployment in the right of way. We also get that the industry needs to do this in a cost-effective manner, that they have to have a return on their investment, and that time is money. The other point I want to make is that we all want the same thing. We want what you want. your customers are our constituents, and we at the local level appreciate the importance of advanced communications to our economic and social benefit. We want to be smart cities. We want to see, I think the previous speaker was talking about what an exciting time this is. We all too are looking forward to machine-machine communications, sensors, driverless cars, smart cities. We want to do that, and we want to get there. And so I think we're with you in that regard. The key is, how do we address the infrastructure challenges that we both face? The other point I want to make is that the vast majority of the local jurisdictions have, to my understanding, worked well with the industry in the deployment of previous iterations of wireless technologies, 3G, 2G, 4G LTE, and so forth. And I'm very confident that we will be able to collaborate for the benefit of your customers and our constituents in the future. But because I think we've been able to work well together, we don't see a need for a broad federal preemption of what has traditionally been the regulatory purview of local communities. So we don't need that sweeping federal preemption, but what I think we do need is engaging in a frank, open dialogue. We need to be educated more, like we are in this session, learning more about the technology itself and the infrastructure requirements. And given the, I think, unprecedented demand now for access to the right-of-way to make these networks hum, if you will, we need the time to develop new models and frameworks that will allow us going forward to balance the competing needs for deployment of this infrastructure with our needs at the municipal level to maintain public safety, accommodate other users of the right-of-way, and first and foremost to preserve the efficient movement of vehicular and pedestrian traffic. So okay. I'm really looking forward to more conversations. I know we're having them here with at the City of Seattle with a number of providers that are seeking access to the right-of-way. And for us here, it's important that the reason why we need time to figure this out, and in cooperation with the industry to develop these new models and frameworks, is that we need to get it right the first time, because whatever accommodations we make for the first entrant, I suspect that the second or third entrant will want a similar competitively neutral approach to their deployment. So we want to make sure that we do it right the first time in a manner that can be duplicated. And like the industry too, we understand that we need to be flexible. That while and we'll talk about it more later, while our great preference is to use that the industry use the existing vertical assets already in the right-of-way, or integrate the design into existing street lights, traffic signals, and so forth. We recognize that beyond that, there are going to be situations where that type of integration and assimilation may not be possible, and where freestanding structures may be required.
Okay.
Those obviously are going to be a little more difficult, but I think the key to this is an ongoing dialogue. I know that my organization, NATOA, earlier this year had a joint session with the industry and the FCC for small cell deployment. We are planning another such event. I really welcome the opportunity to moderate a panel with folks from CTIA Mobility and WIA at the recent NATOA conference. And so I look forward to continuing dialogue with the purpose of developing new models and frameworks that will meet both of our needs, because again, we want what you want.
Okay, thank you very much, Tony. At this time, we're going to turn the presentation over to our sponsors, starting with Kashif Hussain, Viavi Solutions. Kashif?
Thank you, Martha. So I'm just going to spend a few minutes trying to explain. So Paula went into some of the details of what hetnets are and how heterogeneous networks are evolving. So if you all remember, about a few years ago, we used to mostly have macro cells where we used to have coax type cable going from the base of the tower to the top of the tower. That has changed. Now we have fiber to the antenna, irrespective of the type of technology, whether it's CPRI or OPSI. And in the case of, then you have small cells, and the number of small cells it's going to continue to grow. And I'll show you in the next picture how the networks will look like. And of course, RANs, we used to have passive DASs. I mean, now we have distributed RANs, and you have now active DASs and what have you, right? So go to the next slide, Paula, please. Okay, so if you look at on the left-hand side, the traditional cellular network, which we used to remember as a hexagonal, hexagonal cells, now in the 4G, as you densify, you have layers and layers of small cells cells and small cells trying to cover that same area, because just of the network demand that you have, where you have more and more cells required to basically provide the same quality of service. And as you go into a true heterogeneous network where you have layers of networks, it can be Wi-Fi, small cells, DAS, or macro cells. Now this offers a lot of challenges for the operator, from an operator, and as well as the contractors who are working in the field and the network equipment manufacturers, what have you, right? And I've defined some of them from the perspective of basically deployment and managing the networks. Of course, Paula talked about some of the deployment challenges, in fact, from the point of where to find the location and what have you. So I'll talk about that a little bit as well. But if you look at it now, the scalability is one of the key challenges if you think about it, because now it's not about deploying 100 cells in a year. It can be in thousands that you have to do. Interoperability, because not necessarily every different type of cell site is going to be from the same manufacturer. Getting the right backhaul, managing the performance. So it's not just about CapEx anymore. It's also about managing the operational expense as well. And of course, load balancing. When I've spent time and money in deploying a cell, I want to make sure that that cell is being used for the desired purpose. And at the end of the day, it is all about how do you manage them. I mean, ensure that there's not causing interference with your macro network, or the macro is not taking over and basically impacting your small cells, what have you. And return on investment is the logical thing, because that's what the whole purpose is. It's a business, so we need to ensure that we get our money's worth. So if you look at the different challenges that we have, right? I mean, I just talked about, right? How do we resolve this thing? So one of the key things we talked about, maintenance, is scalability, CapEx and OpEx, technology evolution, because now you have to keep on training your resources all the time, right? So what we have been talking with a lot of service providers, operators, and what we are learning in the process, that it's all about how do we automate all these solutions. So I represent the test and measurement side of the world. So from my perspective, it's how we automate the process of testing and ensure that we are delivering what we have promised, right? Meaning, if I have designed a network that can offer, let's say, 100 megabits of service in a certain area, then how do I ensure that I have done all the things right? Meaning, my fibers are working as designed, my connectors are working as designed, my antennas is doing the job they're supposed to, my RF environment is fine. Doesn't matter what the interface is, and doesn't matter what my connection is, whether it's a backhaul, whether it's front haul, or all the way to the RF. Everything needs to be tested and has to be automated, because now I have hundreds of cells to manage, not just a few cells. So the key thing is that we have to automate from the point of inception of a cell. We have to identify where the cells have to go, the right place for the cell, and not necessarily that you will get that location every time, just like Paula mentioned, but you have to look for the right place. Otherwise, you will be investing in places and the traffic may not be there. So there's no point in deploying a cell. So you have to be smart in making that decision. So solutions like we offer solutions like Ariso Geo, which can actually pinpoint locations where you should be deploying a cell to ensure that you're getting the maximum out of the cell. So next slide. So sorry, I'm done actually. So basically the idea here is that we offer a complete superset of solutions from the point of cell deployment to testing each and every interface that is within the network, if it's fiber, coax, RF, what have you, right? And ensuring that the quality of service is managed, whether it's an issue with the backhaul, whether how you have set up your priorities for different users, what have you. So your QCI indicators are done right. And all that information needs to be analyzed and has to be automated and made easy for the operator, so they don't have to hire more and more resources to manage a similar area of network. So that's all I have, Martha.
Okay, thank you very much, Kashif. That was great information. At this time, we're going to move on to Robert Booth with antenna maker Galtronics. Robert?
Yes, thank you, Martha. It's been interesting listening to the challenges that everyone is facing in providing the connectivity we're all looking for, and that's really what Galtronics specializes in. At the end of the day, everything we're deploying, if it's in a mobile environment or a fixed environment, maybe the last item we kind of consider is the antenna, and the antenna is going to make these things connect. So Galtronics' background goes back nearly 40 years ago, actually creating the first antenna for the Motorola brick phone. So in the 70s, we began with focusing on how these things will communicate, and then now today, evolving, we're integrating multiple antennas in these devices so they can connect on the network anywhere, anytime. But the challenges that we're beginning to face now, as you can see in the markets we serve, are immense. Just an example, if you're looking at where much of the data is going to be communicated, and it's going to be focused on consistently throughout the day, is going to be what Paul commented on earlier, is an in-building environment. So in that case, our group, which does home enterprise and networking capability, we develop the antennas that go inside those routers and those access points. For an example, Spider Cloud, which might end up with 6 antennas in that remote, but at the end of the day, it has to be oriented in any direction and still allow the connectivity, and you don't control that. So it's a challenge. And then if you go through the rest of the applications, if it's in building or a stadium environment or outdoor, the challenges even increase more so. If you move to the next slide, I just wanted to comment about how these challenges evolve. If you look at a DAS deployment in building for the kind of coverage we expect today, well, that's a broad coverage reach that you're trying to accomplish. But when you begin to deal with small cells and you end up deploying that access point that I just spoke about a while ago, that's going to give you the need for sectorization so you can increase your capacity. But at the same time, you may want to increase that coverage in a variety of ways. So what that means is you may need a different antenna solution to complement that access point. So in our case, for example, that means we have to focus on an RF pattern that provides the sectorization for that small cell and doesn't have the UE connecting to the wrong access point. So there's a variety of antennas you can see on this slide showing how we do that. But what's key is the patterns that we emphasize in this left-hand corner, where you see that the directivity of that RF pattern is isolated within the building office location and it's not propagating floor to floor. We call it upper hemispheric suppression. So the point is that as you move forward and you talk about flexibility and coverage and isolation, just in this case, you're going to also want to be able to have the right RF coverage that you need to make that possible. And in this case, you can deploy these antennas below or through or above in the ceiling with no degradation. If you move to the next slide, though, the challenge becomes quite significant, and I really like Paula's densification doodle, because maybe I could overlay it on this slide, let's say, and what we're trying to emphasize in this is the variety of antenna solutions that might be needed for intense densification, but the challenges we face as an antenna company supporting the operators and others is what frequencies are we going to need to cover? Are we going to have to cover all the way from 698 up to 6 gigahertz? If we do, in every case, we're looking at the size of this antenna having to grow with regards to which frequencies we're going to cover. And if we look at it as a neutral host, well, then we have other challenges, and that has to do with all the cabling and the multiple ports to support such a site. But when you look at it all together, what Galtronics is doing is we're focusing on an in-depth dialogue with the operators to talk about identifying those frequencies, honing in on the type of propagation that's needed, the gain and other requirements and isolation from those frequencies. But within that, we establish a form factor that is sized appropriately, looks adequate for meeting the zoning challenges that you're going to face throughout the country, which are varied at every different site you're going to be looking at. So in this one slide, the one example you're seeing is a canister antenna, which in essence allows the zoning people to approve one look. But when you look at the densification challenge Paula mentioned, well, within that one look is approved, then we can have a single panel propagation solution. We can have a back-to-back panel solution or a quarter section. So you're, in essence, using a single look, but you're accomplishing all those objectives she had in the gold, silver, and bronze kind of application. At the end of the day, too, you may end up with concealment requirements, as you've seen in the previous slide, or you take an access point where you cannot go and attach to street furniture, and there you've got a combination, in this example, of our outdoor panels attached back-to-back to the radio access point. So our focus is on connectivity and creating the right antenna solution for the market and the application that you're going to need to get this densification.
All right, Robert, thank you very much. Well, at this time, we're going to move on to our discussion topics. We've had some great overviews so far, so we'll have to move rather quickly through some of these topics, but some of them have already been covered. The different tools in the toolbox, obviously, Paula, I borrowed this phrase from you. So maybe you can just give us a little bit of an overview of the selections that operators make when they're looking at different choices, outdoor small cells versus outdoor DAS, and then within the small cells, I know that remote radio heads and integrated small cells are both choices. So maybe you can just give us a quick overview of how some of those choices are made. Paula, can you hear us?
Sorry about that. I double-clicked on the mute there. Sure, be happy to answer that. I don't know that there's a single solitary answer, you know, on how we go about making the distinction between small cells and an outdoor DAS. It certainly takes into, first of all, it's just an absolute clear definition of what we're trying to achieve and what is needed, inside the community, for their communications needs and what the network requires. It also depends on the existing coverage that's there and whether or not you need to do a fill-in or whether you need to handle both coverage and capacity, whether you're making that play or whether you're making a capacity play. So Martha, there's really not one single answer. You've got to take a look at, what you're trying to solve for and go at it with a clear set of eyes, that takes into consideration, perceptions, and it takes into consideration, what's going on within the community itself. Is the community an early adopter, or do they have some concerns? We'll also have to take into consideration, what's going on, in the area in terms of, environmental conditions and even cultural conditions. So Martha, there's not an easy answer to that.
So if the community is an early adopter, does that mean that they're maybe more open to solutions that might be a little more obvious to the eye, or what does it mean if they're an early adopter? It
really does. At least in my experience, is that communities which are early adopters will take a few more risks with you in terms of what it looks like. Now there's an absolute trust factor that comes into play there, and that you're not, my personal opinion is that you don't build anything that you wouldn't have in your own neighborhood, and you can't build something that's going to be an eyesore. I mean, you gotta work with what you're willing to live with. Okay. Kashif, I know that you work with all these different form factors. Do you have anything to add here?
So from our perspective, I mean, when you're talking about whether you're going to do a DAS versus an outdoor small cell, what have you, and all the different type of solutions, to me, it's more about basically talking to different operators and service providers just to support what Paula said, right? It also depends on one more thing, which is like the cost and accessibility aspect of it, right?
Yeah.
And if there is no fiber, you have to find another solution. And of course, you have to manage within your costs. Same thing with from an antenna perspective, how do I get there? Same thing for remote radio head or integrated small cell, right? Like whether I would be allowed to deploy that, number one, and whether I can do it within my cost means. So those are the couple of things that they always have been asked, right? Like if it fits the cost, meaning the budget, then can I have the access to it? So that's how we've always seen it. Now, how do I go and find a location? That truly depends whether it is the right place. For example, I mean, anecdotally, there was a small area where we had a lot of interference issues that we can see in our Ariso Geo solution, basically, when we were running the reports and everything, right?
Yeah.
Now the location is in building. Without solving that problem, we can put sites around it. We were not resolving it. So
okay.
we were able to work with basically, of course, the operator in that case had to work and get access to the building to provide a solution, which then they were able to resolve it to get the maximum out of it. There was a site which was close enough, but it was because of the way the building was, the coverage was not there. And every day when there was a traffic there, you will see a lot of drop calls and all that stuff. So
okay,
it all depends how the accessibility works.
Right. Okay, Robert, do you have anything on the antenna considerations? I know you've given us a lot already.
Well, mainly to add, maybe to go back to Paula's original comments about the need for a toolbox. And I would suggest that for any of these applications, it is a toolbox where you're going to possibly need a WIP solution, and that might be driven by a city's high density metropolitan emphasis. Maybe we're only going to accept WIPs, and so those WIPs have certain requirements and dimensions that you've got to focus on, and that might be one tool. Another option could be panels, but when you look at a panel solution, again, you can only place so many panels on the street furniture like you're looking at right now.
Yeah.
And then if you've got it connected to a remote radio head, well, you can only put so many radio heads on there. So now the next solution may be the canister. And then the canister is driven by that. The size of that canister is going to be driven by the number of frequencies that you're going to need. And then again, commenting on actually defining, well, what kind of power are we putting out at this site? So at the end of the day, yes, it might be that your design has the right look, but the exact location that you need to have that cell could be a challenge because it could already be grabbed. So
Okay.
the antennas portion of it is definitely a toolbox to just grab from whatever is going to work best for you.
All right. And what about backhaul? Randall, I know that you talk to operators as they try to make the decisions about backhaul. Do most operators want fiber if they can get it? Randall, can you hear us?
I'm sorry. Yeah, of course, fiber is probably the preferred option from performance standpoint. But in many cases that's not viable. We're looking at a number of different kinds of solutions. People are looking at a whole myriad. Just as an example, one group we were talking to wants to deploy trash cans that have small cells deployed in them. So, the idea of running a fiber to every trash can, becomes certainly something that's quite challenging. And so, that's probably one of the biggest deterrents to the placement issues that I was talking about, and may speak to, some of the viability of having these pre-wired locations. So it's certainly a challenge.
Well, would these have trash in them as well, or would they be fake trash cans?
They'd be actual, the group we're talking with wants to do actual trash cans that have a Wi-Fi access point and a small cell in them. It's a very interesting and maybe notional idea, but it kind of speaks to this idea of, this distributed architecture, this distributed shared infrastructure that could be placed out there. And again, just take that as an example. But that's certainly where we see the trends.
All right. Let's move on to finding the right spot. Let's talk about it first from the technical point of view. Kashif, I know that this is one of the things that your tools help the operators with.
Definitely. Like I was mentioning before, right? So if you think about it this way, so not every problem will be, you cannot take every problem and resolve it one way. So one thing that we do is basically take the data from live users, try to analyze the data. Based on that, we make the determination, and actually we make recommendations where you need a cell site or a small cell or maybe a hotspot, what have you, right, in that regard. And that's one of the fundamental things. The challenge could be that you have a permitting issue or concealment issue and what have you, right? But at the same time, if that specific problem is not resolved, then basically the investment that is made may not, may not give you the right returns. So what we are talking about is using a solution like Ariso Geo, which actually identifies based on the real life traffic, which are your true busy areas, what is the problem going on, meaning it has an interference issue or anything like that, right? Or high drop connection, lower throughput, and things like that. And it gives you a high, a recommendation with very accurate assessment of where you need to deploy these small cells to resolve that problem. So finding the right place is a key. Like Paula said, and other speakers have said as well, right? The location is extremely important, finding the right location, because if you don't, then you might end up spending more money, finding more fiber or microwave solution for the backhaul in another location. So it will impact your cost structure in that case to get to the right, to provide the right level of service.
Right, absolutely. So once the right spot has been identified, then zoning, permitting. Tony, what insight can you give us? What best practices have you seen from the operators that you've worked with in Seattle and elsewhere?
Well, in speaking with the folks from our electric utility, we have a municipal electric utility here, and our right-of-way permitting folks and land use professionals. What seems to work is when a provider comes with, typically when we deal with site acquisition companies, they might identify a location in terms, desired location in terms of its propagation characteristics. Sometimes without regard to some of the underlying zoning and land use restrictions. So when we can have those conversations early on and can help the site acquisition folks come up with alternatives or alternative placements or alternative designs that would allow them to achieve their objectives, that's always very helpful. So it really helps, again, when the site acquisition companies, in addition to defining a site based on its engineering value, also take a look at and educate themselves about the underlying zoning and land use issues.
And is concealment often a value?
Absolutely, absolutely. Like I mentioned earlier, we're equipped to move quickly in cases where co-location and alternative designs that can be integrated into existing infrastructure, or in some cases camouflaged, is highly desirable and encouraged.
Okay, great.
If this is Robert, but if I could just add one comment about concealment. Concealment can become a major focus without centering around the other aspect of it, which is the propagation, the antenna RF propagation from that concealed type structure. So it's good to work with partners that understand that going in terms of whatever kind of concealment they may be trying to accomplish, whether it's a light structure or something else. At the end of the day, you still got to propagate a signal. So
okay,
put the two together.
Excellent. All right, Tony, I know that you work with a lot of officials from different cities. Do you find that the cities or the counties and the carriers are usually able to come together on pricing pretty quickly, or is that usually a difficult discussion?
Sometimes it's a difficult discussion. It all depends too on the placement. For example, our prices for our electric utility prices for attaching to existing utility poles are published. They're very reasonable. They are less than a private utility would charge. But the whole notion of what represents fair and reasonable compensation for the use of the right-of-way is sometimes, I think, leads to some disagreements. I know a lot of industry members have indicated that we shouldn't be looking at market rates for using the right-of-way. And there may be some value into that, but I think generally we find common ground, and I don't see the pricing, the matter of pricing becoming such an issue that it would inhibit rapid deployment. I mean, we're not looking to make. We certainly want extra revenue for the city where we can, but at the end of the day, we also want the service to be available to our residents.
Sure. Okay, does anybody else have anything on any of these issues before we move on? Okay, great. So skill sets, thanks to Paula, we got some great information on that earlier in the webinar. So we are going to skip over that and move on into validation. Kashif, this is one of your areas.
Yeah, definitely. And that's what I was just talking about in my section as well, right? Because when you are deploying all these networks and how they interact with each other, and when I say different networks, I mean macro cells working with the small cells, working with, DAS and what have you, and the interference problems you are seeing. So the point is, in that environment, what operators really need is the ability to troubleshoot problems like that. First of all, there's a lot of work done on the standard side, where you have a latest feature, ICIC, basically coordinated multipoint, and all that stuff is coming out. On top of it, automation is required when you are going to talk about validation, whether it's, like I said, whether you're doing a fiber test, whether you're doing a coax test or RF test for that matter, or even the backhaul, whether the right priorities are given to the right devices. For example, you have, narrowband IoT coming out, so you need to ensure how things are going to be positioned, because now it's not just about users, it's about different applications and different devices, how they are going to be interacting with the network, and the level of priority they will be needing. So whether you have to make a decision based on at the core level, the parameters you have set, or at the backhaul. Going a step further, if you talk about the optimization aspect of it, if your network is not optimized, and if you put a small cell out, or a DAS maybe, but it is not carrying the traffic it's supposed to be, so that can be a big challenge too. So now you have to not just optimize just the RF performance of it, but actually you have to manage the traffic, and you'll have to ensure that actually during heavy loads and stuff like that, your small cells are what they're designed for, they're working. And the cell which is above that, which is a layer of macro cell, or maybe a couple of layers of LTE macro cells up there, and they are only taking the traffic when they are needed. Right, so basically we talked about the return on investment aspect of it. So those things are all essentials, but at the same time, to do all this thing, you cannot be sending drive teams, you cannot be sending resources out there. So it has to be, all of that stuff has to be taken back. And when we talk about automation, we talk about SON and all that stuff, that has to get implemented. Otherwise, it will become, from an operational perspective, becomes a nightmare, because you cannot have an unlimited, nobody has unlimited amount of resources.
Right, an expensive nightmare, right?
Exactly.
All right. Thank you very much, Kashif. At this point, we're going to get a little bit of an outlook for what's next from each of our panelists before we finish. Tony, starting with you.
Well, I think what's next from our perspective is I know that I've learned a lot here today more about the infrastructure challenges, and this is something that I can take back to our group and help inform our ongoing conversations of how do we generate creative approaches in working with the industry to deal with this unprecedented need for placement of facilities on the right of way. So I'm hoping that we can continue the dialogue, and I'm hoping that there will be increasing and steady cooperation among industry and local jurisdictions. And I might say that I totally agree with I was heartened by Paula's comments that you wouldn't want to build something you wouldn't want in your own neighborhood. And that's the way we feel. Unlike the industry has never had to deal with the complaints from a citizen calling us on their mobile phone to complain about the new wireless tower that went up in an area. So those are some of the unique challenges that we have. So I look forward to continuing education and discussion, and I'm very, very optimistic that we're going to move forward in creating those new models and frameworks that I discussed.
Okay, great. Paula, would you agree with that?
I certainly would. I would add that just the open dialogue amongst all the players, and learning how to better communicate with amongst all of ourselves here, and putting the elephants out in the room, or I think maybe the elks on the table, where we can put it out there. Let's talk about it, and let's end up with a solution and a deployment plan that betters our communities.
Absolutely. Okay, Robert and Kashif are our two vendors here today. Robert, do you have a perspective on what's ahead?
Well, I think clearly working with the operators and neutral hosts, others, to define specifically, looking ahead, what is the broad range of frequencies that we need to tackle? This is already underway. How can we look at, like she's just said, some elephants on that table, which are size, and how do we begin to address what would be an effective compromise that deals with the size but still gets the performance objectives that we need? And then are we really providing the right set of tools that can be used extensively, no matter what setting you're in. So this is an intensive engineering effort, but it's definitely a cooperative effort where we achieve the right intent of the right product for the right deployment. So we're looking forward to this cooperation and working together.
Okay, thank you very much. And Kashif Hussain, Viavi Solutions.
Yeah, the only thing is, I personally think, just like everybody else said it, these are exciting times. I mean, with 5G coming in the future, with Internet of Things and all that stuff, I mean, I think technology will change significantly. The networks, the way we see them today, by 2020, they will not be the same. Not the core of the network, not from the RF perspective, not from the base station perspective. They will change drastically. I mean, we are talking about RF over fiber today. Maybe we'll be talking about RF over Ethernet, because the demands will be changing. So we'll have to just keep an eye on all those changes, and we'll have to keep on adapting and learning. Just like Paula said in the beginning, I mean, from my own perspective, personally, I think that I have to read every day something new to keep myself up to speed on what the technology changes are coming. And they will keep on evolving and changing, and we'll have to all work together to make sure we can deliver the 5G promises that are being made.
Yeah, that's good advice. Okay, and Randall Schwartz.
Yeah, I think that, on one hand, I'd agree, and on one hand, I offer a little bit of a different view. I think that, the evolution of the industry is just at breakneck speed, and the changes and challenges, there certainly are challenges on the technical side. I think some of the biggest changes that we'll see will be in some of the structure of the industry, where we see different kinds of network models, maybe a trend towards more and more shared infrastructure, where you really, we've talked for years about, virtual networking, maybe more of that comes to the fore. Different kinds of business models where different kinds of parties are operating as as operators, new different kinds of operator models. So I certainly think it'll be very, very interesting. And, all of these things we always need to figure out the financial end of things, and building different kinds of business models and business cases so that we can invest in all of these new ideas and new technologies.
All right, thank you very much. I'd like to thank all of our panelists for being here today, and thank you for everyone who joined in the webinar. This will conclude the webinar.